One of the concepts I found to be easy to understand but difficult to remember when it came to test time was the errors related to hypothesis testing. I could figure out that there was an error, but couldn't determine if it was type 1 or type 2. That's what this video will focus on. And as we all learn differently, I'm going to approach this from different angles. First, we need a brief overview of the null and alternative hypotheses because, as you undoubtedly remember, the entire research process revolves around hypotheses. The base assumption is that if you get a result, that result could be due to chance, or not. For example, I noticed that when my family last visited Disneyland, the crowds weren't as bad as I expected. Now, it could be that the day we went was, just by chance, not as busy as others. But Disney had just changed their pricing structure. It's very possible that what I observed was not an anomaly, and that the reduction in crowds that I noticed was due to that stimulus. In other words, not due to chance. The null hypothesis would be that the finding of Disneyland being less crowded was just due to chance. Had we gone on another day, there might have been the usual hordes of people. The alternative hypothesis would be that something happened, in this case Disney's change in pricing, that is correlated with the reduced crowds. So let's apply this example to the hypothesis testing outcomes of type 1 and type 2 errors. Assume we know reality, which of course we don't really. But reality could be that the null hypothesis is true. We just happened by chance to go to Disneyland on a light attendance day. But it could be that what we observed was not by chance, meaning that the alternative hypothesis is true. Well, now let's look at what we could conclude, the research decision. We could decide that the null hypothesis is true. It really was an anomaly. Or we could reject the null hypothesis and conclude that the alternative hypothesis is true. Disney's pricing did indeed have an effect on the theme park's attendance. Now compare the research decisions with reality. If we accepted the null and in reality the null hypothesis is true, we made the right decision. No error. Same thing if we rejected the null and accepted the alternative hypothesis, and the alternative hypothesis was indeed the right one. That would be the right decision. No error. However, for the other two decisions, we would be drawing the wrong conclusions, meaning that there would be error. So the question is, what type of error? Let's assume that the null hypothesis is true, but we rejected it in favor of the alternative hypothesis. In our example, we would conclude that Disney's pricing affected attendance, when in reality it did not. Then we made an error, a false positive, which is a type 1 error. But if the opposite were true, we concluded that we were just lucky to visit Disneyland on a low attendance day, accepting the null hypothesis, when in fact Disney's pricing did have an effect. The alternative hypothesis was indeed true, we would be also committing an error, in this case a false negative, which is a type 2 error. So type 1 error means a false positive. Think of it as a false alarm, as when a fire alarm goes off but there's no fire, while type 2 error is a false negative. It may be worse than an oops, depending upon the example. If the fire alarm does not go off, but there is actually a fire, well, that could be a truly horrific error. Let's use the classic fairy tale of the boy who cried wolf as an example. I'm offering my thanks to Bill Schmarzo of EMC Squared for the idea. If the null hypothesis is that there is no wolf, the alternative hypothesis would be that the wolf is actually there. So a type 1 error or false positive would be the boy crying wolf when there is no wolf present, rejecting the null in favor of the alternative hypothesis. If, however, the boy does not notice the wolf or convinces himself that it's not there, accepting the null over the alternative hypothesis, a type 2 error or false negative would be doing nothing, not crying wolf. Now there are consequences or costs related to every decision, and this example is no different. In the false positive example, type 1 error, there would be the cost involved with killing the imaginary wolf. And if you know the story, you know the boy would also lose a lot of credibility in the process. But in the false negative example, type 2 error, there is also cost, as sheep are expensive and it may be hard to find good help. The most obvious example is the criminal justice system in the United States, where the accused are presumed innocent until they are proven guilty. Thus, the null hypothesis is that the accused is not guilty of a crime. If the defendant is found guilty when in fact he is innocent, we are convicting an innocent person and committing a type 1 error. However, if the defendant is found not guilty when in fact he is, we are letting a guilty person go free, committing a type 2 error. Looking at the costs associated with each type of error, the U.S. has determined that the costs of committing a type 1 error are worse than the costs of committing a type 2 error. Okay, so here's a question for you. Assume your alternate hypothesis is that Disneyland's ads increased attendance at the park, and your null hypothesis would be that the ads have no effect on attendance. You do a research study and conclude that the ads did not correlate with increased attendance at the happiest place on earth. But unbeknownst to you, the ads were actually effective and did influence attendance at Disneyland. Perhaps you did your study on an off day. So we obviously have an error, but what type is it? It's type 2 because you accepted the null hypothesis that your findings may have been due to chance or sampling error, meaning that you had a false negative. Let's try another. You think you might be pregnant. The null hypothesis would be that you are not pregnant, while the alternative hypothesis would be that you are indeed pregnant. So you do an experiment using a home pregnancy test, and the results come back supporting the alternative hypothesis. So you reject the null hypothesis. But if in reality you are not pregnant, what type of error would you be committing? That would be type 1 error because you rejected the null hypothesis when in fact you should have accepted it. The test was a false positive, and you'll have to give back all those cute Disney newborn clothes you just bought. While some might claim that in this case you might be safer to commit a type 1 error versus a type 2 error, because you might be more apt to take care of yourself, believing that you might be pregnant, for example. In research, however, we would rather make the mistake of having a false negative than a false positive. In this case, you might be concerned that you actually have a type 1 error, so you test and retest and retest, as well as holding off on making any kind of announcements until you're fairly sure that you are indeed pregnant. Thus, type 1 errors are considered to be more grievous than type 2 errors. Let's do a quick summary. Type 1 error means that you have a false positive. You rejected the null in favor of the alternative hypothesis when in fact the null was valid. The probability of making the wrong decision when the null hypothesis is true is denoted by the significance level alpha. Type 2 error means you accepted the null hypothesis when in reality you shouldn't have, a false negative. The probability of a type 2 error is denoted by beta. One way I try to remember which is to realize that in both cases you are rejecting one of the hypotheses, rejecting the null or rejecting the alternative. The word null has significantly fewer letters than the word alternative, 4 letters as opposed to 11, and fewer syllables too. So 4 is less than 11, just as 1, or type 1, is less than 2, or type 2. Once you understand the concept, perhaps an easy way to keep track of which is by remembering your ABCs and 1, 2, 3s. 1 comes before 2 and A comes before B. So type 1 error uses alpha when talking about the probability of error, and type 2 error, 2 comes after 1, uses beta, B comes after A, when talking about the probability of a type 2 error. And we usually talk about plus or minus in that order, or positive and negative. So a type 1 error is a false positive and a type 2 error is a false negative. Quiz time. If you reject the null hypothesis in favor of the alternative hypothesis and the null was indeed true, which type of error have you committed? And which type of error is due to a false positive? Which type of error do we researchers tend to consider to be the worst? Remember our criminal justice system. Because of the belief that we'd rather have a false negative than a false positive, social scientists have developed rigorous standards that must be met to justify rejecting the null hypothesis. When you do your own research, you may find yourself chafing at these standards, feeling that you know the alternative hypothesis is true, but your statistics don't quite meet the requirements necessary to support your gut feeling. So you must acknowledge that your results are likely due to chance or sampling error. But now, at least you know why.